So we want to know what is the differential equation looks like, and identify, and then try to solve. A constant, homogeneous constant coefficient equation. So the learning outcomes for homogeneous constant coefficient at the end of this session, you should be able to solve. You should be able to solve the homogeneous linear ordinary differential equation with constant coefficients. So the second order differential equation, you see the pattern of the equation. A y double dash plus by dash plus cy equals to 0. So the right hand side is 0. That means this is homogeneous differential equation. This ABC is referring to constant coefficient, this one. So the differential equation ay double dash plus by dash plus cy equals 0 is the homogeneous constant coefficient ordinary differential equation, with A, B, C are the constants. So how to solve these equations? Ay double dash plus by dash plus cy equals 0. How to solve? So this comes under method of solutions. How to solve? So this is a little bit on theory, but you can straight away solve the problem by considering the final output of this. Because in order to get the solution, you have to start with the step 1. This is something like we want to show or prove how does the final solution looks like. So that's why we have to start with this and then try to solve the problem. So the solution, this is important, the solutions, or you say in your word, the answer of the differential equation be in this form. This is the assumption. We start off with y equals to EMX. And we are interested in finding the M. Finding the M. So what is this M? So we want to find the M. So in order to find the M value, you have to differentiate 2 times because you are solving second order differential equation. So you have to differentiate y 2 times. So dy dx, this is y dash, the first one. Dy dx equals to, you differentiate EMX using the formula for the differentiation of exponential functions. You refer to any calculus book. The differentiation of e power mx is MEMX. Okay, differentiation of EMX, MEMX. And you differentiate one more time, d squared y dx squared, m multiply m squared EMX. This is differentiation 2 times for the exponential functions. Now, you take all this, plug inside the differential equation. That is a y double dash plus by dash plus cy equals 0. So you substitute ay double dash, that is a m squared EMX, by dash b MEMX, and cy CEMX equals to 0. The right hand side must be 0. Now this term EMX and EMX can be factorized. That means you take out EMX and then we factorize. So you put in the bracket AM squared plus BM plus C equals to 0. Now the EMX is the solutions. So it cannot be equals 0. Therefore, AM squared BM plus C equals 0. This is what we call auxiliary equations. So AM squared plus BM plus C equals 0 is called as auxiliary equations, AE. Short form is AE. Remember, yeah? So AE is short form for auxiliary equations. Now, this equation is quadratic equations. AM squared plus BM plus equals 0. And you can find the value of M. So we want to find the value of M using any factorization method or a formula, quadratic formula. That is M equals to minus B plus minus root B squared minus 4AC divided by 2A. So still in step 2, that from DE you transform to AE. So DE stands for differential equation, AE stands for auxiliary equation. Auxiliary equation, in fact, you can memorize this, AM squared plus BM plus equals 0, because end of the day you want to solve this. So to solve auxiliary equation, you must use the formula. The formula comes from algebra. Solving a quadratic equation to find the roots. Normally you say roots because this is quadratic equation. So you have 2 roots. So the general formula, remember here, the formula M equals to minus B plus minus root B squared minus 4AC divided by 2A. And this B squared minus 4AC will lead to 3 different cases. This is what we want to investigate now. So the AM squared plus BM plus equals 0, the quadratic equation, can be solved using this formula. Okay, this formula M equals to minus B plus minus root B squared minus 4AC divided by 2A. This formula is very useful to solve the quadratic equation. So there are 3 cases, class. when you want to find the root of the quadratic equation. So case 1, b squared minus 4ac greater than 0. If this happens, then you have m1, m2 distinct and real, meaning m1, m2 not the same. That means two different roots. The word distinct meaning here different, but real roots. Real means like 3, 2.5, 22 over 3, 7 over 5, and so on. Distinct root. That's why we say distinct and real. Because we have a case 3 where it is not real. So complex, case 3. So case 1, distinct and real. Case 2, whereby the b squared minus 4ac can be equals to 0. So in that case, you have m1, m2 repeated and real. So m1 equals to m2. They are both equal. m1 equals to m2. So this is the problem because you have same roots, m1 equals to m2. Therefore, the solution must have independent solutions, because if you study the theory, the second order differential equation must have two independent solutions. So for case 2, we will have a problem, but we can overcome this problem by using the theory to find two independent solutions. That means two different solutions, because you have y1 and y2 must be independent. So case 1 is okay because m1 different from m2, so you have a y1, one solution, y2, another solution. So they are independent. But for case 2, when you solve the homogeneous constant coefficient second order, since m1, m2 both are same, but we cannot repeat the y1, y2, because y1, y2 must be independent. So there is a way how to make it an independent solution. You can see in the next slides. We will explain to you how to handle case 2. Case 3 is obvious case, b squared minus 4ac less than 0. Less than 0 means is negative value. So m1, m2 will be a conjugate complex. This one we call conjugate complex. That means m1 have real part and imaginary part. m1 alpha plus I beta, m2 equals to alpha minus I beta. So you have both real part and imaginary part. Then we call this as a conjugate complex. This will happen when b squared minus 4ac less than 0. Okay, now we try to simplify the final general solutions. We call this as a general solution for the second order only. Y equivalent to C1 Y1 plus C2 Y2. Y1 is first solution for root M1, and Y2 is another solution for the root M2. And since C1 and C2 still unknown, because we are solving general second order ordinary differential equation, constant coefficient, homogeneous, we cannot find C1, C2 because you don't have initial conditions. This C1, C2 you can find only if the problem is called initial value problems, whereby the initial conditions are given. So this final general solution, you just have to write y equal to C1 Y1 plus C2 Y2. Where the y is EMX. The solution is y equals to EMX. So you have y1 and y2. you can see in the next slide. For case 1, how do we write the general solution? So we already mentioned case 1, distinct and real roots. Because two roots, M1, M2, they are not same. So the general solution will be like this. Y equals to C1 e to the power M1x plus C2 e to the power M2x. This is called general solutions. General solution. So general solution, you must know M1 and M2. C1 and C2 will be the constant. So you just let it be there. Meanwhile, and later on we can find the C1, C2. So this M1 you plug in here, and M2 you put it here. So you already solved the problem for the case 1. For case 2, this is the problem. Case 2, M1 equals to M2. But since you must have two independent solutions, therefore the general solution is Y equal to C1 EM1x, and C2, you see there is X here. If you put without X, then they are both same. I can combine C1, C2, I make it C3, EM1x. So in that case, we fail to solve the second order problem. Because second order homogeneous constant coefficient, the theory says you must have two independent solutions. That means the Y1 not depend on Y2, independent. So you must put X here in order to make it independent. So Y1 EM1x, Y2 X EM1x. Then this solution become general solution. For case 3, this one for the conjugate complex root. So there is a strong theory behind it, how they form this solution. So we just quote the final general solution here. If M1 is alpha plus I beta, M2 alpha minus I beta, then the general solution is Y equals to E alpha X. This alpha goes inside here. And then in the bracket, C1 beta X plus C2 beta X. So this beta is the same, okay, for M1 and M2. So M1 alpha plus I beta, M2 alpha minus I beta. So the general solution is Y equals to E alpha X in the bracket C1 cos beta X plus C2 sin beta X. So this is general solution. Now, we try to solve second order homogeneous constant coefficient differential equation, example 1. See, this is second order, y double dash minus 36y equals 0. So there is no y dash. You know the equation, if you look at the general equation, ay double dash plus by dash plus cy equals 0. The quadratic equation is am squared plus bm plus c equals to 0. So this is auxiliary equation, AE. But here, they repeat the steps. Step 1, step 2, and then finally step 3. This is a good exercise for you, just to try to show for this particular problem, how to find the final answer. So y double dash minus 36y equals 0. To find the solution, what is your y? So we start with y e power mx as usual. You can refer to the previous slides, but that is for the general, to derive the general auxiliary equation. So we are in the process of getting auxiliary equation, AE. So y equals to e power mx, dy dx memx. You differentiate one time, you get memx. Differentiate another time, y double dash is m multiply m squared emx. So now you substitute into this equation, put it this y inside here, and y double dash, put it inside here. There is no y dash in the differential equation. And let us see what you obtain. So when you substitute into y double dash minus 36y equals 0, so y double dash m squared emx minus 36 e power mx equals 0, you factorize, take out emx, m squared minus 36 is 0, then the quadratic equation becomes m squared minus 36 equals 0. So this equation you can factorize. Sometimes it can be factorized. If it cannot be factorized, then you use the quadratic formula, minus b plus minus root b squared minus 4ac divided by 2a. So in this case, if you observe carefully, this m squared minus 36 to 0 can be factorized. So if you factorize m squared minus 36 to 0, you get m minus 6 multiply m plus 6 equals 0. Then the final solution, m1, because you have two m's. Root 1, m1 is 6, and then m2 is minus 6. So you already have two roots. Two roots meaning case 1, distinct and real. 6 and minus 6 are distinct, different roots, and they are real. Real meaning they don't have the imaginary part. So now the general solution. The general solution for these two distinct roots can be written as y equals to C1 EM1x plus C2 EM2x. This is your y, yeah? C1, M1 is 6, so you substitute M1 6, C1 e to the power 6x plus C2 M2 minus 6x. So C2 e to the power minus 6x. So this is the solution for your y. So the final solution for this differential equation is y equals to C1 e to the power 6x plus C2 e to the power minus 6x. And these two solutions, y1 and y2, must be independent solution. Now we look at the second problem, example 2. Example 2, solve y double dash plus 6y dash plus 9y equals to 0. Of course, you can straight away solve the quadratic equation am squared plus bm plus c equals 0. In this case, your a is 1, m squared plus your b is 6m, your c is 9 equals to 0. So you can factorize also m plus 3, m plus 3. So m1 is minus 3, m2 is minus 3. If you directly solve, you can find the root. But in this example, since we are considering this is an example for the beginning, we try to start from the scratch. That means you show all the workings, all the workings step by step. You start with y equals to EMX. You start with this always if you want to show all your works. So you start with y equals to EMX, y dash equals to m EMX, and y double dash m multiply m squared EMX. So, and then you plug in y double dash inside here, this equation. And then y dash you put inside here, and y you put here. So what happened here is when you substitute, you get the following result. Y double dash plus 6y dash plus 9y equals 0. Y double dash m squared EMX plus 6y dash 6m EMX plus 9y EMX equals to 0. Then you can factorize, take out the EMX. Since this is all the steps you have to show, so you have to factorize EMX, m squared plus 6m plus 9 equals 0. Therefore, you have m squared plus 6m plus 9 equals 0. This is quadratic equation because the EMX cannot be equal to 0. This one, it is a solution, so it cannot be 0. Therefore, m squared plus 6m plus 9 equals 0. Then you try to factorize this. So easiest way is you can use the trial and error, intuitive calculation. Then you found out this is m plus 3, and then m plus 3 equals to 0. Then solve this. You have m1 minus 3, m2 also minus 3. So you have two repeated roots. Then this falls under case 2. This is case 2. So in this case, we have problem because we cannot repeat the two roots in the final solution. So if you look at carefully, the final solution, general solution, y equals to C1 EM1x plus C2 x is there. Because this x will make two independent solutions. So the y2 does not depend on y1. So it is an independent solution. So you put x EM1x. So the final solution y will be, you write y equals to C1 EM1 is minus 3 plus C2x EM1x because M2 also minus 3. So y equals to C1 e to the power minus 3x plus C2 x e to the power minus 3x. So this is your final solutions. Y equals to C1 e to the power minus 3x plus C2 x multiplied by e to the power minus 3x. So you have two independent solution. If you combine these two, it becomes general solution. Now, example 3. Two y double dash plus 2y dash plus y equals to 0. 2y double dash plus 2y dash plus y equals 0. This is homogeneous because your gx is 0, homogeneous. Constant coefficient because this is 2 double y, 2y dash, and then this is 1, y equals to 0. Now you start with y equals to EMX. Y equals to EMX, this is what we call the assumption that we have to make. You differentiate 2 times y dash m emx, y double dash m squared emx. So you take all this, plug inside here, y double dash and y dash and y. Put inside. And then try to factorize and find the auxiliary equations. So 2y double dash plus 2y dash plus y equals 0. You substitute 2m squared emx plus 2m emx plus emx equals 0. You take out emx as usual because this is not 0. Then you have 2m squared plus 2m plus 1 equals 0. This is your quadratic equation. So 2m squared plus 2m plus 1 equals 0. Sometimes it's very hard to factorize. So we try to use the formula. Use the formula. The formula you have to memorize. The formula to solve 2m squared plus 2m plus 1 equals 0 is m equals to minus b plus minus root b squared minus 4ac divided by 2a. This is one of the best, the last choice, because sometimes you will not be able to use normal factorization or intuitive calculation to get the roots. Even it is 2 roots, but still sometimes you will waste time in factorizing or by doing trial and error. If you can do it very fast, then it will save your time. But if you want a very quick one, then let's say you try 1 or 2 or 3 attempts, so you cannot do factorization or by intuitive calculation. Then you can use the formula m minus b plus minus root b squared minus 4ac divided by 2a. So you substitute m equals to minus 2 b is 2 minus 2 plus minus b squared, that is 2 squared, 4 minus 4, a is 2, c is 1, divided by 2a. 2a, a is 2. So minus 2 plus minus 4 minus 8 minus 4 divided by 4. But the problem with the root minus 4, the answer is 2i. This one you got to study complex numbers. In complex numbers, root of minus 4 is 2i. Root of 4 is 2. So this is root of minus 4 is 2i. Now you want to simplify. Minus 2 plus minus 2i divided by 4 is minus 1 over 2 plus minus I over 2. So that's why you have m1 minus 1 plus I divided by 2. And then you are m2 minus 1 minus I divided by 2. So m1 is minus half plus I over 2. This is your m1. And your m2 is minus half minus I over 2. So your alpha is minus 1 over 2 half minus half, and your beta is half because this is plus minus. So your beta is half. Your alpha is minus half. Now with that, you can find the root. You can recall back now the m1 alpha plus minus I beta, m2 alpha minus I beta. Therefore, alpha is minus half, beta is half. This is complex roots. These are the complex roots. And final general solution, you have y equals to e alpha x in the bracket c1 cos beta x plus c2 sin beta x. So the alpha is minus half. You plug in here. in the bracket C1 cos beta of x plus C2 sine beta of x. So this is your final answer. But don't forget that the C1 and C2 will be there. So this one we cannot find at the moment. We just leave it as it is. But we already found the general solutions. General solutions. So this is the example. We want to solve this problem. Y double dash plus 3y dash plus 1y equals to 0. This is the example. This is the last slide, class. So please write down, yeah? So in this case, the m squared, your a is 1, b is 3, c is 1. So we are not going to repeat the whole thing, but I want to, we can solve directly. So you write down AE, auxiliary equation. Since your A is 1, AY double dash, plus BY dash, B is 3, and CY, C is 1, equals 0. So your auxiliary equation is M squared plus 3M plus 1. M squared plus 3M plus 1. It is very difficult to factorize, so we have to use what we call the quadratic formula, minus b plus minus root b square minus 4ac divided by 2a. So if you check b square minus 4ac, b squared is 3 squared, 9, minus 4 multiplied by 1a, and then multiply c1, so you get 4. So 9 minus 4, 5. So if you, in this case, 5 is greater than 0, then we can conclude that the roots are real and distinct. So your m, now you substitute your m equals to minus b. So minus 3 plus minus b squared. B squared, 3 squared, 9, minus 4ac, 4, divided by 2 multiplied by a. A is 1. So you get 2. So your m will be minus 3 plus minus root 9 minus 4, 5. So 3 plus minus root 5 over 2. If you use your calculator, if you simplify root 5, you will get 2 real roots. And this example 4 is belong to case 1. Case 1 whereby the root m1 and m2 are distinct and real. So your m1 is minus 3 plus root 5 over 2, and your m2 is minus 3 minus root 5 over 2. So your general solution will be, y equivalent to c1 e to the power root 3 plus minus 3 plus root 5 over 2 x plus c2 e to the power minus 3 minus 5 over 2 multiplied by x. That is your final solutions. Any question, class, here? Example 4. This is the last slide for homogeneous constant coefficient. Any question? Example 4, class. Example 4. So example 4, I repeat here, the final answer is y equals to C1 e to the power root 3 plus root 5 over 2x plus C2 e to the power minus 3 minus root 5 over 2x. Of course, you can simplify this answer because root 3 plus root 5, you can simplify this divided by 2, but it will be in the decimal number. So you will have a different value. Root 3 minus 3 plus root 5 over 2, that is your M1. M2 minus 3 minus root 5 over 2. So you can simplify. So that is this is the slide number 25, the last slide. So you can find more problems in the tutorial, but it is not given at the moment. Yeah, as Dennis. You are okay. As Dennis. So Dennis is asking question. One more Dennis. Can I just solve? One more Dennis. Can I just solve it by using calculator and not showing the working? Yeah. Okay, so there are many ways. There are many ways you can solve this problem without repeating the all the steps. So any questions so far on homogeneous constant coefficients? Any question, class? So you can refer to any notes, any reference book for more problems. You must remember the homogeneous constant coefficient is because you are only considering the auxiliary equations. So that's why, so it is not a difficult problem. But the most difficult one is inhomogeneous. So we will do not do inhomogeneous for today because we have to finish this one first. Homogeneous Cauchy-Euler equations. The non-homogeneous comes under this part, 2.4 and 2.5. So today we just cover homogeneous constant coefficient, and then afterwards we move on to homogeneous Cauchy-Euler. So far homogeneous constant coefficient. Any question, class? Homogeneous constant coefficients. So if you go through the slide, we already finished. If you have any problem, please you can ask me now, because after that we will not repeat all this. So you can try to solve all these problem again by yourself. especially example 4. So example 4 is a good exercise, and I already given the solution, but still you can try by yourself. So now we're going to want to upload the second one, 2.3. Yeah? So I'm going to upload 2.3. So the second part for today, 2.3, you must be very careful here, because this 2.3 homogeneous Cauchy-Euler equation. So the word here Cauchy-Euler, this is very important. Otherwise, it's very hard for you to differentiate with other types of differential equation. We are still using the word homogeneous, same, but it is called Cauchy-Euler. So this is very specific type of equation. We call it a very special type. So what is this Cauchy-Euler or Cauchy-Euler equation? How does it looks like? So this is very important, class, because you want to know how does this equation looks like. So by the way, by the end of this session, you must identify and solve Cauchy-Euler differential equations. So first, we want to introduce Cauchy-Euler or Cauchy-Euler. So this is very long equation, linear Cauchy-Euler differential equation. Homogeneous meaning your gx is 0, this one. Later we will put 0, because we start with the general equation. So this is linear because there is no y terms, something like y squared left hand side. No. So how do we know linear Cauchy-Euler differential equation? You see this term an, these are the constant. Yeah, you don't worry about this. an minus 1 until a1 and a0 are constant. But the most important thing is the degree of x. Here, power n is the same as the order of the derivative, dny dxn. If you see here, this one is clear, x power 1 and dy dx. So the degree of x here 1. If I put n2, x squared d2y dx 2. So then it becomes 2. N is 2. Degree 2. Order 2. That's why the word same. Same meaning what? Same meaning the degree of x and then the order. That is the meaning of same. Degree and order. Degree and the order. On the right hand side, you don't worry, is function in terms x only. X only. But this one, gx, we will put 0 later because it is homogeneous. So you must identify this Euler-Cauchy. You have x term here together with dny dxn, x power n. And then the power will be reducing. If I put n2, this will be 1. So like that. If I put 10, this fellow will be 9, 8, 7, and so on. So how to solve this? So in order to solve, first we take one good example, the linear second order. Second order Cauchy-Euler differential equation. We just, in fact, we only concern very much on second order because this is the best example we can give to you so that you can understand and build up your foundation very strongly. Homogeneous Cauchy-Euler equation focused on second order. So you see A, B, C are constant. This is second order. You have x squared. X squared. This is not constant coefficient. This is Euler, Cauchy-Euler. Constant coefficient, there is no x squared. That is the difference. Later on, you have to do the analysis. You have to do the analysis by yourself. What is the difference between constant coefficient and Cauchy-Euler? This is the after you finish. But here, you got to understand very well what is Cauchy-Euler ODE. What is this? So a good example is ax squared d squared y dx squared plus bx dy dx plus cy equals to gx. But this gx will be equals to 0 later. Okay? Because you already say homogeneous. Homogeneous meaning the gx will be 0. Later on we will put 0. But the most important thing is the power of x must be same as the order of the differential equation. The derivative, the derivative. X squared d squared y dx squared plus bx dy dx plus cy equals to gx. So the power and the derivative, order of derivative must be the same. And this one, x dy dx, same. A, B, C are constant, so you no need to worry about. So solution of this, how to solve? Second order homogeneous Cauchy-Euler equation. You see the right hand side, now 0. If not 0, then we have to study some more. That is another problem. How to handle the non-homogeneous part. Now we are concerned about homogeneous. So homogeneous meaning your gx is 0. So we don't consider the gx. The homogeneous Cauchy-Euler equation must take this form. The format of the equation is ax squared y double dash, but we do not know the a and b and c. That is okay. That is later on we will give the value and we show you in the example. But at the moment, we are solving the problem, the method to solve the problem. So where do we start? What assumption we make? Where is the starting point? The starting point is y equals to x power m. Just now for constant coefficient, you start with y equals to e to the power mx. But for the Euler-Cauchy, it is totally different. Y equals to x power m is the solution. But what is m? We have to find. Our job is to find the m value. What is the m? So in order to find m, you have to differentiate y dash, y double dash. So y dash m x m minus 1, y double dash m m minus 1 x m minus 2. You take all this, plug inside here, y double dash, and then y, plug inside. Then you have this one. So you substitute y double dash with this, y dash with xm, mxm minus 1, y with xm, and then you simplify this. So you throw away all the x, and you obtain am m minus 1 x power m, because this cancel off, class. This one cancel off, this one cancel off, cancel. am m minus 1 x power m, b m x m, c x m equals to 0. So you can take out all these xm, simplify. It's very important. This theory you must understand very well. You take out xm, in the bracket you have am m minus 1 plus bm plus c, and this one cannot be equals to 0 because equals to 0, sorry, this is equals 0 because your xm not 0. So this is am squared minus a plus bm. So you can factorize m, b minus a, and then plus c equals 0. This is called auxiliary equation, class. Okay, it's very important. Am squared plus b minus am plus c equals to 0. So this equation you must memorize. For second order homogeneous Cauchy-Euler equation, the auxiliary equation is am squared minus plus b minus a multiply m plus c equals to 0. You must memorize this. So you can straight away from this equation, a is what? You identify. A is what? B is what? C is what? From here, you can create this equation. And this equation is called AE, auxiliary equation for Cauchy-Euler. CE, Cauchy-Euler. Cauchy-Euler. So, from this differential equation, this is Cauchy-Euler. You straight away create this very fast. This is very powerful. If you can create still, then you already find your m. Then we can move on to general solution. So ax squared y double dash plus bx y dash plus cy equals 0 is differential equation. And the auxiliary equation we already proven, so no need to repeat. You just have to write am squared plus b minus am plus c equals 0. But don't forget that your y1 is x power m1. Y2 is x to the power m2. Because you started with y equals to x power m, the solution. And step 3, you solve the AE. You solve this equation. And then you give the final answer, this one. This is the final answer. Y equals to C1 Y1 plus C2 Y2. So how do we write this, class? Again, since this is homogeneous, you have case 1, case 2, case 3. Because your equation is quadratic equation. You see, when you solve the am squared plus b minus a m plus equals 0, you will have two roots, but 3 cases. So case 1, your m1 not equals to m2. This is called distinct and real roots. Distinct meaning simply layman's term, we call it difference. 2 different roots. But it must be real. without any imaginary numbers. So the general solution, don't be confused, yeah? Different from the constant coefficient, y equals to C1 x to the power m1 plus C2 x to the power m2. This is the final output. If you change this, if you write in another form, then your answer will be incorrect. So you must remember, for homogeneous Cauchy-Euler equation, if it's two distinct roots, real, the solution is y equal to C1 x to the power m1 plus C2 x to the power m2. And C1, C2, you just leave it as it is because we cannot find C1, C2 at the moment because you are not given an initial condition. But the most important thing is what is M1 and M2 and the way how you write this general solution. You see, in constant coefficient, you wrote y equal to C1 e to the power M1x plus C2 e to the power M2x for the case 1, distinct in real roots. But here it is different. If you exchange this, then it is not acceptable. That means you are confused. So it's very important. Later on, you do your analysis, your own analysis. What is the difference and what is the similarities? The homogeneous part is the same. You solve the auxiliary equation. You have 3 cases. So we already saw this case 1, and now case 2. Case 2 is a repeated real root. That means your m1 equals to m2. When you solve am squared plus b minus am plus c equals 0, if you get m1 equals to m2, then it is repeated root. So repeated root, the general solution is like this. Y equals to C1 x to the power m1 plus C2 x to the power m2 multiplied by ln x. This one is already proven in the theory. You can find the proof either in calculus or in algebra. So we just quote this only. But if you don't have ln x or ln x, then these two will be the same. So we can take C1 x to the power 1, C2 x m1 and put it C3 x to the power m1. In that case, you are solving first order, not second order. Second order meaning, theoretically speaking, you must have 2 independent solutions. So that's why by putting ln x here, there is no way they are same, because y1 x m1, y2 x m1 multiplied by ln x. So there are no way you can combine it and put it in one. It's impossible. So that's why these repeated real roots, for case 2, you have to take care. Now, for case 3, this is a quite difficult one, because conjugate complex roots. So because when you solve the quadratic equation, am squared plus b minus a m plus c equals to 0, you will find that one of the possibility is the complex roots. So how do you write? So you will have m1 alpha plus minus I beta. That means m1 alpha plus I beta, m2 alpha minus I beta. M1 equals alpha plus I beta, M2 alpha minus I beta. So your general solution y, x to the power alpha, you put it here, in the bracket C1 cos beta ln x together. That's why, because this should be independent solution. So beta ln x plus C2 sine beta ln x. So this beta beta put ln x together. So beta same. Alpha, this alpha same. So you cannot write C1 beta x. No. Beta ln x plus C2 sine beta ln x. This is the general solution. So take note, yeah, for homogeneous Cauchy-Euler equation, the solution for three cases, all must have independent solutions. Cannot be the same. Even here you have y1, y2, one is cos, one is sine. So this is independent. Now we look at the example. So you can solve this very easily. It is up to you. You can follow these steps as shown on the slides, or you can do your own way. So it is up to you how you solve, but end of the day, we want to have correct general solutions. The general solution must be the correct one. Of course, if you do the steps, you can see the detailed solutions. But if you don't want to do the steps, you can directly find the auxiliary equation, and then you can find the general solutions. Most important is the auxiliary equation, and then finally the general solutions. So altogether there are 4 steps, but you can cut short and make it 2 steps. If one step, then it will not be understood well by others. So it is better to have 2 steps minimum, because the auxiliary equation is very important. But if you can, because sometimes auxiliary equation also you can use intuitive knowledge, your own thinking, and then you can give final answer, general solution. So it is all depend on your general solution. Okay, in this case, x squared d squared y dx squared minus 2x dy dx minus 4y equals to 0. This one is obviously homogeneous Cauchy-Euler second order linear differential equation, because the right hand side is 0, yeah. Right hand side is 0 means homogeneous. And x squared same as d squared y dx. This is x dy dx. So here a is 1. Your b is minus 2. Your c is minus 4. Therefore, your auxiliary equation is am squared. A is 1, m squared. B minus 2 minus A, 1. So minus 2 minus 1 minus 3m plus C. C is minus 4. So therefore, your auxiliary equation is m squared minus 3m minus 4 equals to 0. That is auxiliary equation. Straight away from the definition, we can get the auxiliary equation m squared minus 3m minus 4 equals 0. But here, they are showing all the steps. So step 1, you start with y equals to xm. Then y dash m xm minus 1. Then y double dash m minus 1 x m minus 2 using the power rule, yeah? M minus 1 is m minus 2. So you take all this, plug inside here, y double dash, y dash, and y. So when you plug in all, you will get this one. So d squared y dx squared, m minus 1 x to the power m minus 2, dy dx, x m minus 1. Your y is x power m. So if you plug in all the derivative, and then you rewrite again x squared mm minus 1 xm minus 2 minus 2x mxm minus 1 minus 4x power m equals 0. Then you simplify x squared, this cancel off, this x minus 1 cancel off. You have m minus 1 x to the power m minus 2m x to the power m minus 4x to the power m equals 0. Now, you can take out this xm class. You can take out this xm, all take out because these are same term. So you take out and you factorize. M squared minus 1 minus 2 minus 3m minus 4. And this one must be equals to 0. Because x power m cannot be 0 because x power m is the answer, the solution. So therefore, these terms must be equal to 0. And this term can be obtained from here also. That is the power of the shortcut. So if you substitute A is 1, your B is minus 2, your A is 1, and your C is minus 4, you get m squared minus 3m minus 4 equals 0. So there are two ways to do this. One is by memorizing this formula, you get m squared minus 3m minus 4 equals 0, or by derivation, you can derive this equation. So it is up to you how you get. So the important thing is m squared minus 3m minus 4 equals 0. This is quadratic equation, and we try to factorize this. You can factorize this. M squared minus 3m minus 4 equals 0. If you factorize, you will get m plus 1, bracket, yeah? Bracket m plus 1, multiply another bracket, m minus 4 equals to 0. Here it is not shown. This kind of thing you have to do your own exercise. But I'm giving you the answer here. The factorization, the factors are m plus 1, m minus 4 equals 0. You can double check later. Therefore, or you can use the quadratic formula. It's up to you. There are a few ways to solve this equation. If it's easy to factor, then you can use a trial and error or intuitive thinking. You can solve. If it gets complicated, then you use the quadratic formula. So if you solve this, you have two distinct real roots, m1 minus 1, m2 4. This is case 1. So the general solution is already stated, y equals to c1 x to the power m1 plus c2 x to the power m2. So therefore, your y here equals to c1 x to the power m1. m1 is minus 1. Plus c2 x to the power m2. m2 is 4. So this will become your final solution. Y equals to c1 x to the power minus 1 plus c2 x to the power 4. So this is your final solution. Now, this is another example. Your second order homogeneous Cauchy Euler equations. So here you have A is 4. Here is 4. B is 8. Your C is 1. So A is 4. B is 8. C is 1. Okay, so please write down, yeah? A is 4. B is 8. C is 1. So the auxiliary equation AE, AM squared, that is 4M squared, plus B minus A. So B is 8, A is 4. So 8 minus 4, 4. 4M plus C, 1. So your auxiliary equation is 4M squared plus 4M plus 1 equals 0. This is directly from the general equation, AE equation for the Cauchy-Euler equation. AM squared plus B minus AM plus C equals 0. You match that with, you can see 4x squared D squared Y x squared plus 8x dy dx plus y equals 0 is homogeneous Cauchy-Euler equation. You must clarify that first. Very clear. If it's not in this form, then you cannot use the AM squared plus B minus AM plus C equals 0. So your auxiliary equation is 4M squared plus 4M plus 1 equals 0. Now, if you factorize, you will get 2M plus 1 multiplied by 2M plus 1 equals 0. Therefore, your M1 is minus half, and your M2 also minus half. But in this case, they are showing all the steps. So you start with y equals to x power m. So those of you who are not familiar with the method, you can try this. This is a good exercise. You exercise yourself, you familiarize yourself, then you can compare the solution with the direct formula. So y equals to x power m, y dash m x m power minus 1 by using the power rule, y double dash m m minus 1 x m minus 1 minus 1 minus 2. So you take all this thing, plug inside the original differential equations. You plug inside, then substitute, and then you go to simplify. So 4x squared d squared y dx squared plus 8x dy dx plus y equals 0. So if you simplify this, 4x squared d square y dx square m minus 1 x m minus 2 plus 8x m x m minus 1 plus your y x power m equals 0. So this x squared can cancel off. This x can cancel off. So the remaining term is 4m m minus 1 x to the power m plus 8m x to the power m plus x power m equals 0. Now, this one, x power m, you can take out. Take out, you factorize. So you have 4m squared, this one, 4m squared, and minus 4m plus 8m is 4m plus 1 equals to 0. So this is your auxiliary equation, which can be obtained from directly from this also, same. You can obtain from here also. So if you put A is 4. This A is 4. So you get 4. This A is 4. And your B is 8. 8. And your A is 4. So 8 minus 4, 4. So B minus A is 4. And your C is 1. C is 1 from here. Your C is 1. So you have 4m squared plus 4m plus 1 equals to 0. This is your auxiliary equation. And this auxiliary equation, we have to find the roots. So solve auxiliary equation 4m squared plus 4m plus 1 equals 0. You want to factorize this, you no need to use the formula because it's very easy to factorize. So 4m squared plus 4m plus 1 equals to 0. If you factorize, 2m plus 1 multiplied by 2m plus 1 equals to 0. So you have two terms, 2m plus 1 multiplied by 2m plus 1. So you have m1 and m2. 2m plus 1 equals to 0. So therefore, 2m plus 1 equals 0, write down here. Therefore, m1 is minus half. And another 2m plus 1 also equals 0. And then m2 is minus half. So in this case, your m1 minus half, your m2 also minus half. So this is what we call repeated roots. Real, but repeated. So this is quite confusing part. How to write two independent solutions. You can see in step 4, the general solution. Since the two roots are same, but we are looking for independent solution. Cannot be the same. So y equivalent to C1 x to the power m1 plus C2 x to the power m1 ln x. Don't forget to write this ln x. So therefore, your final answer y is equals to C1 x to the power minus half plus C2 x to the power m1 also. But if you write m2, still answers the same, x to the power minus half and then multiply by ln x. If you give this answer, your answer is perfect. But still again, the C1, C2, we cannot find the value at the moment because if you want to find C1, C2, you need initial conditions. In that case, the problem will be IVP, initial value problems. But at the moment, we are not dealing with the initial conditions. So this example is a good example to show you how to handle if you find two distinct roots, repeated roots. Normally you say in algebra, when you solve a quadratic problem, you say roots, R-O-T-S, either real roots or complex roots. So now we move on to the next example. Example 3. 4x squared d squared y dx squared plus 17y equals 0. This is homogeneous Cauchy-Euler equation, even though you don't have the dy dx. In this case, the value for b is 0. B is 0 because there is no dy dx. You know the differential equation for homogeneous Cauchy-Euler is ax squared d squared y dx squared plus b dy dx plus cy equals 0. You must remember that is the general formula for the Cauchy-Euler. So if you go back to the first slide on Cauchy-Euler, so the equation is ax squared y double dash plus bxy dash plus cy equals to 0. This is general homogeneous Cauchy-Euler second order linear differential equation. You must remember that. You must match this equation 4x squared d squared y dx squared plus 17y equals 0 with that general equation. Then from there, you can find your A. A is 4, your B is 0, and your C is 17. So your auxiliary equation will be AM squared, that is 4M squared plus B minus A, 0 minus 4 minus 4M plus C. C is 17 equals to 0. So this is the auxiliary equation. But here we want to derive from the beginning. This is a good exercise again. We want to derive, show all the ways how to get the auxiliary equation. So you start with y equals to x power m. I repeat the same process. Y equals to x power m, y dash equals to mx m minus 1, and y double dash m minus 1 x, m minus 1 minus 1, m minus 2. So you take all these things, plug inside d squared y dx squared, and you don't have y dash, you put y here. So 4x squared multiplied by m minus 1 x to the power m minus 2 plus 17 y x power m equals to 0. So that is what you can see in the next slide. So you substitute d squared y, this term all for d squared y, and this one is for x power m. So you have 4x squared, 4x squared. So Chia, can we write m1, what, m1 for m2 1? Which one is this?
Sir, just now the question.
Which one? Which one?
For example, actually originally the answer is m1 is equal to -1, m2 is equal to 4, and then my question is, can we write oppositely?
Oh, okay. Can.
Okay.
Which one? Which one? Which slide?
I think just now.
Slide number 19. No.
Forgot already, sir.
No. Is it in Euler-Cauchy?
Yeah, still Cauchy, sir. Yes.
Example 1.
Wait, I guess is m1 is not equal to m2. Yeah.
Okay. So example 1, m1 minus 1. Sorry, you wrote m1 for m2 minus 1.
Yes,
right?
sir. That is my question.
Oh, yeah. In this case, okay. In this case, yeah. Okay. Can. Yes,
Okay.
yes. You can exchange this. Yeah. Okay.
Thank you, sir.
Okay. Yeah. Welcome. Okay. No problem. A good question. Yeah. This is a confusing part. No problem. You can exchange. Yeah. M1, M2, you can exchange here. But let me see. Yeah. Okay. That is example 1. Now we are in example 3, right?
Yes, sir.
Yeah. So for you, it is good for you if you use the shortcut, the powerful one. Yeah, you said. So this one, 4m minus 1, because this x squared cancel off, and you have 17xm equals 0. This xm you can factorize. So 4m squared, and then minus 4m plus 17 equals 0. This is the auxiliary equation. But this equation you get from here easily. If you memorize this, am squared, that's why I tried to say just now, am squared. So a is 4, 4m squared. So your b is 0, minus a is 4. So 0 minus 4m plus c equals 0. C is 17, yeah. This C is 17, yeah. So the B is 0, A is 4. So you can get this equation from here. It doesn't matter how you get this auxiliary equation. End of the day, you have this auxiliary equation, then you move on to factorization. This one is very lengthy, but I can tell you. A is 4, B is minus 4, C is 17. You are solving quadratic equation, yeah? The formula is, the quadratic equation formula is minus B. In this case, it's very hard for you to factorize. This is the difficulty that you will face. This one, not easy to factorize because this is complex root. Normally complex root, you must use the formula m equals to minus b plus minus root b square minus 4ac divided by 2a. Write down, yeah? So we are using that formula. Here it is easy because they already wrote the answer, but you have to do the calculation. So the calculation goes like this. Write down, yeah? A 4, B minus 4, C 17. So your M equals to minus B. So B minus 4. So minus 4. Plus minus root B squared. Minus 4 squared. 16. Minus 4 A 4 C 17. Divided by 2A. So 2 multiplied by 4, 8. So you have 4 plus minus root of 16 minus 4 multiplied by 4 multiplied by 17. If you simplify, you get root of minus 256. Write down here. Root of minus 256. So root of minus 256 is 16i. 16i. So you have 4 plus minus 16i divided by 8. They wrote very easily. 4 plus minus 16i divided by 8. So double check, yeah, with your calculator. 4 divided by 8, half. 16 divided by 8, 2. So your M1 is half plus 2i. M2 is half minus 2i. The 2 comes from 16 divided by 8. 16 is root of 256. So your final answer will be alpha half. So your general solution, y equals to x power alpha. So alpha is half. Put it here. This is your y. Equals to, this one you must write because we want to remember this. Y equals x power alpha in the bracket C1 cos beta ln x together, because ln x is fixed, plus C2 sine or sin beta and then ln x. Ln x is fixed. It's already in the general form. But the problem is the alpha. Alpha, y equals to x power alpha. Alpha is half. C1 cos beta. Beta is 2 here. So you take these 2, plug inside here. Just like that. 2, that means C1 cos 2 ln x. Plus, actually this is your y1. Plus, x power alpha, C2 sin. This 2 is beta. Either you take from here or here. The same. So this is 2 ln x. So your final answer will be y equals to x power alpha C1 cos in the bracket 2 ln x plus C2 sin in the bracket 2 ln x and then close bracket. This is your final solution. But you must remember, yeah, there are 3 cases involved. Always remember there are 3 cases involved. So that's why you have 3 roots. 3 roots and 3 cases. For Euler, Cauchy-Euler, as well as for the constant coefficient. But the final solution slightly different. So you must know the difference between these two. Any question, class? So this is the last slide. So if you have any question, you can ask now. Anything that not clear? For the homogeneous Cauchy-Euler, there is no question yet, no exercise, but please wait. It will be uploaded via uLearn later on. And you got to just wait, be patient. In fact, I'm moving slightly ahead because the notes will be available later on. So go back again to the slide. I want to summarize before I stop. This topic basically on higher order differential equation. So far we focus on second order differential equation. So I want to summarize this, and then what is next. You see, today 2.2 and 2.3 is about homogeneous two types, constant coefficient and Cauchy-Euler. There are two types. So both are homogeneous. Homogeneous meaning the right hand side, you saw the gx must be 0. But you already knew what is constant coefficient, what is Cauchy-Euler. Now, the 2.4, so we are not going to today, we are not going to do today, but I just want to explain what is this 2.4. 2.4 is to handle non-homogeneous constant coefficient equation. Basically, that is the objective of undetermined coefficient method. Because non-homogeneous, meaning the gx is not 0. So we cannot use the method that you studied today, which is for the homogeneous part. You start with y equals to e to the power mx for the constant coefficient. And for the Euler, you start with y equals to x power m. But for the non-homogeneous, the slides are not available here. I'm just giving you the verbal scenario for the next lecture. So for the non-homogeneous, we have to use undetermined coefficient method. So what is undetermined coefficient method? This is what we will do later in the next lecture. So we will study the method. Basically, this is the method to solve the non-homogeneous part. In some problems, this undetermined coefficient method will work. It works. But in some cases, because we cannot guarantee, this undetermined coefficient method is a trial and error method. It is not definite. It is not guaranteed. You are not very sure that you will get the solution. So we try. If you cannot solve the problem using undetermined coefficient method, there is another method called variation of parameter method. This variation of parameter method is to solve more complicated non-homogeneous problems. And we will make use of the idea of Wronskian, W, which you studied in the previous lecture, how to compute the W. But not only just compute, but there is more detail. But by the way, basically, it is, we will make use of the Wronskian. So that is in a variation of parameter method.